The Mariana Trench is the deepest point in the ocean, roughly 11,000 feet. Only two successful attempts have gone down there, as well as a wealth of sea life lives down there. In 2012, director James Cameron went to the bottom of the Mariana Trench, nicknamed Challenger's Deep. This is regarded as an engineering feat, as the pressure down there is equal to 118,000 kilopascals. Pictured here is the bottom of the trench. Although he is the first successful man to make it to the bottom of the trench, there was another attempt that would result in a cracked window and not much else. The main purpose of the mission was to observe life and to also be the first human to make it to the bottom. Although no life was observed, but others hope that hidden in the sand at the bottom are tiny sea cucumbers. The submarine needed a large amount of light to be shown on the bottom, as little light makes it to the bottom of the ocean that deep. As well as a tiny pilot's chamber to hold James Cameron as he reached the bottom, as well as a large amount of weights, as sinking to the bottom would take quite a lot of time to get there. However, James Cameron wasn't the first person to reach the bottom. The trip by the USS Tristy was the first to make it to the bottom, but however, they quickly returned to the surface as a cracked window appeared on the hull of the ship. Pictured here are two styrofoam heads. The larger one is a normal one you can buy at the store, and the smaller one is the same head exposed to the amount of pressure you'd experience at the bottom of the Mariana Trench. Just as we have adapted our machines to go deep down, so have biological life forms. On the left is a blobfish when it's in dry land, and on the right is it when it's at the bottom of the trench. It has no bones, so allows it to handle the pressure better than life forms with bones could. To further explain the ideas of fluid pressure, here's a quick demonstration. Here we have two beakers. Beaker 1 is representing the Pacific Ocean. Beaker 2 is representing a big pool. Now the dimes here are representing submarines going to the bottom of the pool and the Mariana Trench. Now the question is, which one has more pressure? Well, obviously this one has more volume than this one, but if you notice, they're the exact same height. The water level is the exact same height. That tells us is the height is what matters, not the volume of the liquid. Now if we go back to the equation, it's rho GH. Rho being density. Now we obviously know that the Pacific Ocean has a lot of salts, so I'm going to put some salt in. Now that changes the density of the water, thus changing the pressure on the liquid, on the dime. And if, let's say this pool is built on a moon colony, since the moon has different acceleration to gravity, this is going to have less density than this would on Earth. But again, the exact same height. So the thing that stays constant here is the height.
Alright. So, as for how planes fly, is due to Bernoulli's principle. If I am pronouncing that right, don't judge me. And that is, if air speeds up, its pressure is lowered. And with that, the air goes faster above the top of a plane's wings, which creates an area of low pressure and generates lift for the plane. Basically, the plane rising, which goes into the pressure is lower above the wings of the plane, allowing it to fly, along with the pressure below it being higher, basically vice versa. And here's my poorly drawn plane right here, with this area right here being the lower pressure. And then this area right here being higher pressure. There you go.
hydraulics work? Hydraulics are very basic. The basic rule to hydraulics is pressure is distributed evenly throughout a liquid. A little force is applied to create a bigger force on the other side. There are many uses for hydraulics. Hydraulics are used commonly in cranes, forklifts, bulldozers, garbage compactors, and any other machine that we need to do large amounts of work with little force. It makes things easier to do, like moving objects or picking things up. As in car lifts used in mechanics, they take cars and they use little force to lift cars up a long distance. Hydraulics is a very simple and easy physics to apply a small force on a little end with little area of pressure, and when pressed down, the pressure is evenly distributed throughout the hydraulic system, so that allows it to do just as much work and to equal the pressure on either side, so you're able to pick up more and push more. It is this common thing to a water gun. When you push in the lever and water squirts, it is the same basic principle in science as a crane.